In this video, we gonna talk about the double integral over general region. The thing that we have been studying is gonna be the double integral. However, the region turned out to be easy. It's gonna be rectangle region, and you see that you'll be able to set up. It's gonna be just integral from A to B, integral from C to D, and dx dy kind of. And that come from the curve that you have turned out to be the rectangle. However, for this general region, you see that the region S turned out to be any region bounded by between two curves. So you have the region S given in this picture, and you have this region bounded between the curve y equal to g1x and y equal to g2x. From your instinct, it's going to be just you're going to run in this way. So you're going to run the variable y. So the thing that we're going to do is going to be we're going to have y gonna run from the bottom curve to the top curve. Let me put some colors in. So you have the yellow curve down here, and you have the top curve up here. Okay, so you see that you have the curve y lie between the purple and the yellow one, and you have x line between A to B, and this one kind of look like rectangle. This one, you know that it's going to be, hey, it's look like rectangle. However, you see that this one is going to be the curve, the bottom curve to the top curve. Okay, so from the bottom curve to the top curve, the thing that you see is gonna be you're gonna have y gonna run from y equal to g1 to y equal to g2. Okay, so this is what I will highlight, or I will set it up. So you see that y is gonna run from g1 to g2. Okay, so y gonna run from g1 to g2 dy. And this one, you see, this one will give you the inside integral. Okay, so it's going to be something like this. And you have x going to cover from A to B. So you have x will cover from A to B. And you have this from A to B and dx. Okay, so you see that it's going to be set up like rectangle. However, the curve that we have for y gonna cover inside. So when you have two curves, you're gonna have curve in the inside parenthesis, and you're gonna have the constant outside parenthesis. So I'm gonna mention here for the conclusion that the curve is inside. Okay, so you have curve inside and you're gonna cover the constant outside. So the meaning for the curve inside mean that you have variable y lie between two curve, and the variable y turn out to be the inside parenthesis or the inside integral. In a similar manner, you see that if it turns out that you have x lie between two curves, you have x lie between h1 and h2. So you have x equal to h1y, and you have x equal to h2y. Okay, so you have x lie between h1 and h2. So for this one, you're gonna be able, okay, so you're gonna be able to have x gonna run from h1 to h2. So it's gonna be from the blue curve to the red curve. So it's gonna be from the blue curve to the red curve. And you have y between C and D. So you have y between C and D. Okay, so you have y between C and D, and x between the blue curve to the red curve. So you have this one, and you're gonna be able to find the double integral in the way that you have x between the left side and to the right side. So it's gonna write down, this one is on from the left to the right. So this one is going to be from less than to more than. Okay, so this one is going to be left to right. So it's going to be from less than to more than, and that is going to give us the correct direction or positive direction. So it's going to be from left to right. And you have this one. So you have x between this h1 to y, from h1y to h2y, and you have y line between c to d. So let me give you two examples. So you have to find the double integral of y minus x dA, where S is the region bounded by the curve y equal to 2x and the parabola y equal to x squared. And you see that this one is y equal to 2x. You have this graph down here. Okay, so you have y equal to 2x, and you have y equal to x squared down here, and you have y equal to 2x up here. And you see that the way that you're gonna run is gonna be, it's going to run from less than to more than, so it's going to be up down direction. So it's going to be from the yellow one to the purple one, and here you have y between two curves, so y must run first. Okay, so y is inside. So from this picture, the double integral that you can set up, so it's going to be y minus x and y inside. So you have dy inside, and you're going to put the yellow curve down here, and you're going to put the purple curve up here. So you're going to have y equal to x squared, and you have y equal to 2x. Okay, so this one will be from the yellow curve to the purple curve, y equal to 2x. Okay, so that is going to be how we set up the inside integral. And for the outside, you're going to take a look at, you have x going to cover from 0 to 2. So it's going to be from 0 to 2. So it's going to be 0 to 2 for the outside. So you see that it's going to be from less than to more than. So it's going to be 0 to 2. Okay. And this one will be dx. Okay. So you see that the color is quite okay for this one. Okay. Let me just erase this guy, and I use the red color. So you see the feeling of the outside integral and the inside integral from this picture also. Okay, so the next picture is if you view the same region. So this one is the same region. However, if you view the function in terms of x equal to instead. So when you have this purple guy, okay, so it is the same curve, but this one is written in terms of x equal to y over 2. And you have the yellow guy is written in terms of x equal to square root y. Okay, so you see that you can set up by using x inside. So for this one, x is inside. Okay, so for x is inside, you have the double integral. So it's going to be the left one, which is x equal to 1/2 y, to outside. So it's going to be x equal to root y of y minus x dx. Okay, so this one is the yellow one and the purple one. Okay, so that is gonna be the left to right. Okay, so in the left to right direction, as I indicate by small arrow in the picture. And you have the outside one. The outside one is gonna be the range for y. The range for y is gonna be y gonna come from 0 to 4. Okay, so y gonna cover in this direction from 0 to 4. So you have integrate 0 to 4 dy. Okay, so you have to set up in this case. The first one is going to be you have x inside and you have x outside. And the thing that I like you to see will be they are not just interchange the order. So you see that you may feel that, hey, can I just use the interchange by I just switch this guy to the inside? Okay, so this one cannot be done in that way. So this one is not equal to, if you just switch, so you can have y equal to x squared, y equal to 2x, and you have integral 0 to 2, something like this. This guy cannot be done for this kind of double integral. It's not the same as in the previous section. Okay, so this one cannot be just switched because these guys are not constant. Okay, so the reason why this one cannot be done because this integral is not constant. They are not constant. So if it turned out to be constant, like rectangle that we had in the previous section, you'll be able to just interchange the parentheses or interchange the double integral. However, not the case for this integral. So this one you cannot do something like this. Okay, so this one is wrong. Okay, so this one is wrong. So we not gonna be able to like compute the double integral by doing the x dy in that form. The correct one turned out to be this guy. Okay, so the correct one turned out to be you need to like see the picture in another aspect for x equal to and for x equal to and rewrite the double integral in a different way. So we not be able to just interchange the order. So it's going to be just you have to rewrite the picture and you have to have x equal to, and it's going to be from the left to the right, and you'll be able to like have it the correct one. I will try to evaluate for value for both of these integral in order to see whether they are the same. Okay, it must be they must be the same. So this one we're gonna show that these two guys are the same by evaluating them. So let me first evaluate the inside. So when we see something like this, we would just compute the inside integral, and you compute the inside integral by integrating dy. So you integrating y minus x dy. So the thing that you're gonna integrate will be integrate y dy. So you would get y squared over 2, and you integrate x dy, and x here is a constant with respect to y, so it's gonna be xy, and you're gonna have y equal to x squared and y equal to 2x, and you would just put them, so it's gonna be 2x squared over 2 minus x times 2x minus x square over 2 minus x times x square. Okay, so this one will be just this term. And then you have 4x square over 2, and you have 2x square minus x to the 4th over 2. Okay, and you're gonna have plus x to the 3rd. Okay, so this one will be just the integral that we have. And you see that we're gonna copy down the outside. So it's gonna be 0 to 2 and dx. Okay, so this one will be integrate 0 to 2 dx, and you gonna get rid of these two guys, and you integrate x to the fourth over 2. So for this one, you're gonna get negative x to the 5 over 5, and you have 1/2 outside. Okay, so you have x to the 5 over 5, and you have x to the 4 over 4 from, okay, so you're gonna have is from 0 to 2. So this one will turn out to be 2 to the 5th over 10 with the negative, plus 2 to the 4th over 4. Okay, so that will be when x equal to 2, subtract by x equal to 0, so you would just get 0. And this one you get 2, and you get how much? You get 4, right? So it's gonna be 4 subtract by 3.2. Okay, so 32 over 10 is 3.2. So it would give you just 0.8. Okay, so that the integral for you have the first setup dy dx. Okay, the second one, okay, so the second one I'm gonna evaluate the inside integral. You're gonna evaluate the inside integral. So you integrate this guy with respect to x, so you have y dx, so you must have yx. Okay, and you have x dx, so you get x squared over 2. Okay, so this guy will be yx minus x squared over 2 from x equal to y over 2 and x equal to square root y, and you have y root y minus root y square over 2. Okay, so that is gonna be this integral. Let me resize this guy a little bit. Okay, so I can have enough space right now. Okay, so I'm gonna plug in y over 2. Okay, so I'm gonna plug in y over 2. So I minus y times y over 2 minus y over 2 over 2. So you get, so it's gonna be y over 2. So it's gonna be y over 2 square over 2. So you plug in x equal to root y and x equal to y over 2 to the integral that you already integrate. So you integrate, you get x squared over 2. So for this one, it's going to be y to the 3/2 minus y over 2. and you have 1/2 y square. Okay, so you have 1/2 y square, and you have minus y square over 8 for the final term. Okay, so it's a little bit messy. Okay, so you would just integrate this guy. Okay, so you see that you may combine these two guys. Okay, so you may combine these two guys together first before you continue on this one. So you see that you get y to the 3/2 minus y over 2, and this one can be written as 4/8, so it's going to be negative 3/8, 3/8 y square. Okay, and you now gonna copy the outside integral from 0 to 4 dy down here. Okay, so it's gonna be integral 0 to 4 dy. So for this one, it's gonna be, you integrate y to the 3/2, so it's gonna be y to the 3/2. Let's use other color. So you get y to the 3/2 plus 1 over 3/2 plus 1 minus y square over 2 times 1/2. Okay, and you have 3/8 y to the third over 3. Okay, so from 0 to 4, and you're gonna just get rid of 3 and 3. Okay, so you would just get, for this one, it's gonna be a little bit messy number here. So for this one, you have 4 to the 5 over 2 times 2/5, that one term, and another term will be 4 squared over 4, and you have 4 to the third over 8. Okay, hopefully I will get the correct answer. For this one, you would just have minus 4. For this one, you would just get minus 8. Okay, and for 4 to the 5 over 2 is gonna be 64 over 5. Okay, so it's gonna be 64 over 5. So for this one, it's gonna be 12.8. Okay, 5 over 64, so it's gonna be 12.8 minus 12. So this one is gonna be 0.8. So you see that sometime, okay? So when you deal with this double integral, you may have to you may have to choose the correct ways to integrate in order to obtain the same answer. Okay, so you have the same answer, but the first one and the second one seem longer. Okay, why did the second one longer? The thing that you can notice will be, you see fraction. Okay, and for this one you not have any fraction, so for this one gonna lead you to the shorter version of the same calculation. The integral part is not that difficult, however the thing that difficult turn out to be the fraction part that sometimes we can avoid by take a look that we're not gonna use this guy to integrate, even though it can be done and it gives you the same or the correct answer anyway. Okay, so that is going to be the trick for this topic also. The next one, okay, so the next one is going to be this picture. And this picture quite easy. You see that it's going to be the region, and you like to integrate x squared dA, okay, and we have the region D bounded by the parabola y equal to 2x squared and y equal to 1 plus x squared. So for this one, I'm gonna just set it up for you. So you see that you have y between two curves, and this guy is the yellow one and this guy is the purple one as before. Okay, so let's take a look at this guy a little bit bigger. And you see that you have x lie between negative 1 and 1. That's gonna be the cover that we have for x. Okay, so you have x between negative 1 and 1. So you see that from these two guys, y must be inside. Okay, so from this guy, you know that y is inside. Okay, so we have y run between two curves, and you're gonna have in this picture like this. So you're gonna have integral from y equal to 2x squared and y equal to 1 plus x squared. Okay, and you have the function is x squared, and you're gonna have dy because y is running, and you would just have x. So the x, okay, so the red guy, the x that gonna be written here is gonna be covered from negative 1 to 1, and that's all. Okay, so for this one, it's gonna be this setup, and we're not gonna set up in another way because it seems difficult. So this one is seem manageable already and everything, no fraction at all. Why we bother to find another way? So for this one, you must compute the inside. Okay, so you must compute the inside. The thing that I will circle turn out to be this term. Okay, so I'm gonna integrate this term first. Okay, so I'm gonna integrate this term. Why can't I? Okay, good enough. So for this one, y equal to 2x squared. So let me compute only the in the box first. So you integrate x squared, so you would just get x to the third over 3. Okay, so it's going to be just x to the third over 3, and it's going to be y equal to 2x squared to y equal to 1 plus x squared. So you have 1 plus x squared over 3. Okay, so it's going to be 1 plus x squared over 3, and you're gonna have sorry, I make a mistake. I integrate with respect to y, sorry. So for this one, you are integrating with respect to y, so it's not that difficult. So it's going to be x squared times y, okay? X here is a constant that I just mentioned. Okay, so it's going to turn out to be just constant multiple, and it's going to be x squared times y from y equal to 2x squared to y equal to 1 plus x squared. And so you get x squared 1 plus x squared minus x squared. What is going to be 2x squared? Okay. So you're gonna just plug in y equal to 1 plus x squared, subtract by 2x squared. So you're gonna have x squared plus x to the fourth minus 2x to the fourth. So you have x squared minus x to the fourth, and you have integrate negative 1 to 1 dx. Okay, and then you gonna have integrate x squared minus 4. So this one will be x to the third over 3 minus x to the 5 over 5. And it's going to be from negative 1 to 1. Okay, so it's going to be from negative 1 to 1. So it's going to be 1 over 3 minus 1 over 5, subtract by negative 1 over 3, negative 1 to the 5th over 5. Okay, and so this one will be 1/3, 1/5, minus 1/3. So it's going to be plus 1/3, and it's going to be plus 1/5. So it's going to be minus 1/5. Okay, and then this one will be 2 multiplied with, so you have the LCM equal to 15. So it's going to be 4 over 15 for your final answer. Okay, so this one will be the solution for this integral. So you just integrate this one and you just set up this one in only one way and you'll be able to integrate it. Okay. The next one, example 9, I will skip this one a little bit and I'm gonna do example 10 with you first, and then I'm gonna leave you for homework. So you see that you have S is the region bounded by the line y equal to x and y equal to 2x. So if you sketch the curve for this region, so you have y equal to x and y equal to 2x. So for y equal to x, it's going to be just 45 degrees. So it's going to be like this. So this one is y equal to x. And you have y equal to 2x. Okay, so it's going to be the straight line like this. Y equal to 2x. Y equal to 2x. Okay, so you have y equal to x and y equal to 2x. And you have x gonna run from 1 to 3. Okay, so you're gonna have x gonna run from 1 to 3. So this is 1, 2, 3. And you see that the region turned out to be this one. Okay, so it's gonna be from 1 to 3. Let me draw something nicer. It should be like this. Okay, and the region is turned out to be somewhere in the middle here. Okay, so that is going to be my region S. And you see pretty clear that this one, you have y is going to run between the yellow one and the purple one. So the yellow one is y equal to x, and the purple one turned out to be y equal to 2x, and you have S, that curve. So you gonna have this guy gonna run in this direction. So it's gonna going up like this. Okay, and you gonna have the double integral. So you have the double integral and you have y equal to x to y equal to 2x. Okay, so this one is the inside. Okay, so y must be inside. Yeah. So y must be inside, and you're gonna have log absolute x over y d what dy. Okay, y square dy, and you're gonna have x gonna cover from x equal to 1. Okay, so it's going to be from 1 to 3. So this one will be your x. Okay, so this one will be your x that gonna cover from 1 to 3. So that's gonna be from 1 to 3, okay, for dx. So you see that this one is the setup that we can do from this picture. And I'm gonna leave you for doing the integral for me, okay, similar to example 8. Let's go back to example 9. Okay, so let's go back to example 9. That is going to be our final example for this clip. So we like to evaluate this integral. Okay, so you have integral over s of x to dy squared dA. So you now have to make the decision for dA. So dA can be dx dy or dA can be dy dx. Okay, so dA can be dx dy or dA can be dy dx. And the thing that you see here that is going to be if you have x e to the y square dx dy or x e to the y square dy dx. So they seem okay, right? They seem okay. However, when you integrate, you see that the thing that you are facing with are different. So for dx dy, the thing that you face turn out to be integrate x squared. Okay, so it's going to be e to the y square, and you have integrate x dx. However, if you have for the second one, the thing that you're gonna have outside is gonna be x, and the thing that you're gonna integrate turn out to be e to the y squared dy. Why I did this for you to see which one can be done or which one cannot be done. So you see that if you're gonna integrate x dx, so this one is okay. So it's gonna be just x squared over 2, quite easy. However, for this guy, you integrate e to the y squared dy. So this one is impossible to integrate. Why this guy is impossible to integrate is because we not be able to use by part in order to integrate this guy. We not be able to use this basic substitution. We not be able to use any technique that we have been studying last semester. So for this one, it's kind of impossible to integrate e to the y square. Okay, so like I mentioned last semester that some integral we not be able to integrate even we use the technique of integration. It's not the same as derivative. Derivative, we be able to derive every function. However, for this one, we not be able to integrate this function. And the thing that we learn this semester is going to be we can use the Taylor series in order to give the approximation for the definite integral that we may like to find. Okay, so for this one seem not we not be able to integrate. Okay, so we not be able to integrate this one. So we cannot use dy dx. Okay, so we cannot use dy dx. So we end up with only the first choice. So we're gonna use the x dy. Okay, so we're gonna use the x dy in this case. Okay, so let's sketch the picture. So let's sketch the picture. So you have S is the region bounded by the y-axis, the line y equal to 4, and you have y equal to x squared when x positive. So we gonna just have the line like this one. Okay, so let me just use this guy, and you have y equal to 4, which is this straight line, y equal to 4. And you have y equal to x squared. Okay, so y equal to x squared, so it's going to be this parabola. So you have y equal to x squared. Let me use this down here, y equal to x squared. Okay, and you have only for x positive. Okay, so you have only for x positive. It means that you have only on the right side. And the thing that you see first is going to be, can we find the intersection point? So we do need this intersection point. This one is going to be just 4, I know. This one is going to be just 0. Okay, so this one is going to be just 0. And this one you have y equal to 4, and you're going to have, you see that this one is going to be running here. Okay, so it's going to be running from x equal to 0, which is the y-axis. So this one is x equal to 0, right? And this one you need to solve for y, so you're going to have x equal to root y. Okay, I said it wrong. It's going to be, you need to solve for x. Okay, so you have x equal to root y. So this one is going to be your left curve. Okay, so the left curve and the right curve that we mentioned before. Okay, so you have your left curve and the right curve. What color? The green one. Okay, so you have the left curve, which is x equal to 0, and you have the right curve, which is x equal to root y, and the region is turned out to be the region that you have bounded here. Okay, so let me use some highlight. Okay, or just, okay, so it's going to be somewhere here. Okay, so this one is the region that you are working on. So you see that this is my left curve, and my left curve is x equal to 0. You just put x equal to 0. And your right curve is x equal to root y. Okay, so you have x equal to root y. So x equal to the left curve and x equal to the right curve, and you have y gonna cover from where to where. So you see in this picture that y gonna cover from 0 to 4. Okay, so y gonna cover from 0 to 4. So y cover from 0 to 4. Okay, so that is gonna be our setup. Okay, so this one will be, you're gonna integrate from x equal to 0. Okay, so it's gonna be inside, right? So it's gonna be integrate from 0, x equal to 0 to x equal to root y. Okay, and you're gonna just have x equal to 0, x equal to root y, and you would just copy down e to the y squared. And the outside, let me highlight some color for you. The outside that we're gonna copy down later. And you see that you can just plug in. So it's gonna be e to the y squared, and you have root y square over 2 minus 0 square over 2. So this one will be 1/2 e to the y square times y. Okay, so it's gonna be integrate from 0 to 4 dy that we can just copy from the top. Okay, so for this one, you have dy, you have dy like this. And now you may just apply the integration by substitution. You would let u to be y squared, and you have du equal to 2y dy. So your y dy must be 1/2 du. So y dy is 1/2 du, okay? And this one will be e to the u square, 1/2 du. And you have also 1/2 from the pink guy. And you have y equal to 0, u equal to 0, y equal to 4. You have u equal to 4 square equal to 16. Okay, so this guy will be y equal to y square equal to u, and you're gonna integrate 0 to 16 of this. So you would just get 1/4 e to the u from 0 to 16. So it's going to be 1/4 e to the 16 minus e to the 0. So you would just get 1/4 e to the 16 minus 1. And that's it. Okay, so this one is called the double integral over the general region. This one is just the first preparation for the difficult one. The difficult one turned out to be, it's going to be about changing the order, and it's going to be about evaluate the double integral that kind of more difficult than this one that you may have to like switch the order of the integration that we're gonna do in the next 2 clips next week. Okay, so that is going to be the topic that we have. Okay, so I'm gonna stop here, and we're gonna do more on example 11, 12, 13, 14, okay, in the following clip. Please do example 10, okay? I will discuss this guy during the recitation.